So what I'm going to do is I'm going to take this opportunity to explain scientific notation. And so there's scientific notation and there's standard notation. And so what you'll notice for these problems, the ones on the left-hand side are right now in standard notation, and the ones on the on the right are in scientific notation. So I'm going to flip them. I'm going to put the ones in standard notation into scientific notation and the scientific notation into standard notation. So I'm going to start with number 1. The first thing that you need to do is you need to take your decimal and move it over enough places so that the number that you get, which we call your coefficient, is between 1 and 10. So I'm going to do this right now. I'm going to move it over 1, 2, 3, 4 places. And so what my coefficient is going to be is 8.57. Then you multiply it by 10, and now I need to decide the exponent. Now, if I take a small number and make it bigger, so taking 0.000857 and make it into 8.57, my exponent is going to be negative. If I take a really big number and make it smaller, then your exponent is going to be positive. So in this case, since I took a small number, made it bigger, it's going to be negative exponent, and it's just how many places you move your decimal. So I moved it over 1, 2, 3, 4 places. So this is going to be 8.57 times 10 to the negative 4th. Okay? So let's look at this next one. Here, I need to take, there isn't actually a decimal here, but there's an implied decimal here, and I need to move it over 1, 2, 3 places because 9.84 is between 1 and 10. So this is my coefficient. So the 9.840, and then I'm going to multiply it by 10. Now I have to figure out the exponent. I took a big number and made it smaller. I took 9,000 and made it into 9. So my exponent is going to be positive, and since I moved it over 4 places, 1, 2, 3, it's going to be times 10 to the 3rd. Okay? Let's look at this next one. I've got 340, so I'm going to take the implied decimal right here and move it over 2 places, 1, 2. So my coefficient is 3.40 times 10. Now, I moved it over 2 places, and I made a big number, 340, smaller by making it 3.40, so it's going to be times 10 to the 2nd. Okay. For the last one, I'm going to move my decimal place over 2 places so that my coefficient is between 1 and 10. So it's going to be 1 times 10. Now, I took a small number, 0.01, and made it into a bigger number, 1. So this is going to be to the negative 2nd. Okay, so what you should notice is if I take a number, if I take a small number like this and make it bigger, I'm going to be using a negative exponent. If I take a big number and make it smaller, like 9.84, it's going to be a positive exponent. Because basically what this is doing is if I were to actually multiply this out, I would get 9,000. Okay? While here, if I were to multiply 1 times 10 to the negative 2nd, I would get this small number. Okay? Next, I'm going to be taking a number that is numbers that are in scientific notation, and I'm going to be converting them into standard notation. So what I have to do, since this is 10 to the 5th, I need to take my coefficient, which is here, and I'm going to move my decimal place 5 places. Now, since this is 10 to the 5th, I need to make this number bigger. Okay, so I'm going to move my decimal place to the right in order to make the number bigger, and I'm going to move it 5 places. So I've got 1 place, 2 place, 3, 4, 5. So where all these where the space is, that's going to be, I'm going to put zeros in there. Okay. So this number will become 9, 5, 6, and 3 zeros after. And let's make sure that this makes sense. There was a small number, 9.56 times 10 to the 5th, and by putting it into standard notation, I made it bigger, which makes sense because this is 10 to the 5th. If it were negative, I should have made it smaller. So that's just a nice way to be able to check yourself. Let's do this one now. Since this is 10 to the negative 4th, I need to make this coefficient smaller. So in order to do that, I'm going to move to the left. and I'm going to move to the left 4 places. So 1, 2, 3, 4. So the decimal will go right there. Where these spots are right here, I'll put zeros. So it should be 0.000, and then my 623. So again, let's make sure that this makes sense. I've got a number here times 10 to the negative 4th. The negative means that I need to make the number smaller. And yeah, this number is way smaller than 6.23. So that works out fine. Let's do the next one. I've got 1.1 times 10 to the second, which tells me that my number is going to be made bigger. So I need to move my decimal to the right. So it's going to be 1 place, 2 places. So it's 1, 1, and then since there's that gap right there, I need to put a 0, and I'm good to go. Okay. For the last one, if you look, 10 to the 8th, I'm going to have to make this number bigger again. Remember, if the exponent's negative, it makes it smaller. If it's positive, it makes it bigger. So I need to move this decimal place over 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. So this is just going to be 33 and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now, some people ask me, do I always need to write stuff in scientific notation? No, you don't. But this is kind of a pain in the butt. It's a really big number. We'll even get ones later on in the year where you have 10 raised to the 23rd. So imagine having to write 22 zeros afterwards. That's why scientific notation is so nice, because it lets you take really, really small numbers like this and make them more manageable. And it also lets you take really big numbers like this and also make them more manageable. And that's all there is to scientific notation and standard notation.